let me give you an example over here. So I hope this becomes more understandable because it's very abstract so far. I don't expect you guys to really grasp totally what is going on here. So what we want to do is that we want to find the inverse, the multiplicative inverse of this polynomial f, which is x3, x5, x plus 1, and our primitive, irreducible polynomial p is x8, x4, x3, x plus 1. So let's see how do we do so. Remember the extended Euclidean equation. So let me draft it down easily. So I'll do all the computation and I leave all the computation for you so that later on you can refer to this one and understand what we've done. So again, my irreducible polynomial capital P is equal to x to the 8 plus x to the 4 plus x to the 3 plus x plus 1. And then our function f, other function is x to the 6 plus x to the 5 plus x plus 1, okay? So we said that when we want to do this operation, we have to do the GCD algorithm and use the extended Euclidean algorithm to find the inverse. So let's just go and find the GCD first. So in order to find the GCD, you have to divide these two things with respect to each other. So let me go to the next page, and I keep all such computation there. So remember that we are working, the coefficients are in Z2. So we are doing mod 2 over coefficients. So the first thing we want to do is that we have to divide x8 plus x4 plus x3 plus x plus 1. We need to divide this one too. x6 plus x5 plus x plus 1, right? This is our f, this is our polynomial p. So remember in high school, how do we do this math? So we have to match this highest degree with this highest degree. So we are missing 2, so we multiply to x2. All of this, so we would get x8 plus x2 times x5, we get x7 plus x2 times x, we get x3 plus x2, right? So now we add them together. So 1x, let me write this one. So this would become 2x. Let me do this one. The first one I will do, very tedious computation. 2x8 plus x7, right? Plus x4. I just have one x4 plus 2x3 plus x2 plus x plus 1. We said that, according to here, we said that, let me write it in red so that you guys remember. We compute mod 2 over coefficients, right? Why? Because our group K is Z2, which is equal to 0 and 1, right? So the coefficients that we defined for this group, let's go back over here. So we said that the K is actually F2, which is Z2, right? So this is the only we can get these two values. So for those for those coefficients that we've computed, we have to apply a mod 2. So because of that, so this, after applying what I said, we get x7 plus this 2 would get canceled, right? This 2 would get canceled. x7 plus x4 plus x2 plus x plus 1, right? And then we continue. So x7 is greater than x6, so we have to continue. So we have to match them. So we have to multiply everything to x. So let me do so. We get x7 plus x6 plus x2 plus x, right? So if we add them up together, x7 and x7 would get canceled because we get 2x7 and then mod 2 becomes 0. So that would get canceled. So I will left with x6 plus these two would also get canceled. This two would get canceled. So I get x4 plus 1, right? And then we have to continue. So this one matches. So just multiply to 1. I would add x6 plus x5 plus x plus 1. So now these two, we get rid of these two and this two. So we get x5 plus x4 plus x, right? So we are done. Because the degree of x is less than x6, so we would stop over here. So remember this x5 plus x4 plus x. So this is the result that we were looking for. So writing the GCD, I can say that I can write that x8 plus x4 plus x3 plus x plus 1 is equal to x2 plus x plus 1 multiplied to x6 plus x5 plus x plus 1, right? Plus the remainder, x5, x4 plus x. So x2 plus x1, x2 plus x plus 1 times this one plus this one, right? So if I go back here, I have this one times this one plus this remainder, I'll get this equation over here. Remember the division? So according to the extended Euclidean algorithm, I have to continue until I get the remainder to be 0, right? To the just the GCD algorithm. So that means that now I have to continue. That it means that I would take this one out, and with this two, so I would say x6 plus x5 plus x plus 1 equals 2. I have to divide this one to the remainder, right? So let me go do that math on the next page. So I just want to keep things simple on this page. So this one was operation number 1. For the second operation, I have to do x6 plus x5 plus x plus 1. I have to divide this one to the remainder, x5 plus x4 plus x. So if you just do this math, we need to add the x to match them. So we get x6 plus x5 plus x2. So these two get canceled, these two get canceled. I get x2 plus x plus 1, right? And done. I don't have to go further because the degree of 2 is less than 5, so I'm set. We go up and we say that we rewrite this equation as x time x5 plus x4 plus x plus the remainder, which was x2 plus x plus 1. So the remainder is not 0. We continue. We do now x5 plus x4 plus x. We divide this one by the remainder. So let me go and do the math over there. So what we were trying to do was to do this division. x5 plus x4 plus x divided by x2 plus x plus 1. So we need to do x3. So we get x5 plus x4 plus x3. These ones would get cancelled. We get x3 plus x. We need to continue with x. So we get x3 plus x2 plus x. So now these ones would get cancelled. We get x2. And the degree are the same. We have to continue with 1. So we get x2 plus x plus 1. This would get cancelled. We get x plus 1. Okay, so that is the remainder that we got. So I go up and I can rewrite that equation as x3 plus x plus, what did I get there? x3 plus 1 multiplied to x2 plus x plus 1 plus the remainder, which was x plus 1. And then I continue again, where I haven't got the remainder 0. So I continue with x2 plus x plus 1 with respect to x plus 1. So I do one last one. So we do x2 plus x plus 1 divided by x plus 1. So I just apply x and I get x2 plus x. So this whole thing would get canceled and the remainder is 1. All right, look like we're done. So this was equal to x times x plus 1 plus the remainder was 1, right? And then the next line, obviously, the remainder is going to be 0. So we would just halt here, right? And if I continue to divide this thing divided by this, the remainder is, of course, going to be 0. So which means that the GCD of these two are 1. This is the GCD of f and my function p equals to 1. So then I just stop there. And this is like, we know that these two are co-prime because the GCD is 1. So now we should be able to compute the inverse of P. So the inverse of P exists. All right, so let me change my color so that we don't get mixed them. So I need your full attention from here because it gets a bit, you might get lost. So just follow with me to rewrite this equation in a backward, and then we would be able to compute the inverse of P. So remember that the way that we want to compute this inverse, we are going to use the extended Euclidean algorithm from now on. So we start from the last equation. We had 1 equals to, from this one, I can rewrite that 1 equals to, I take this one on the other side, so I get that x2 plus x plus 1, right, minus x times x plus 1, right? So this last equation, I keep 1 over here, and then I just rewrite this equation, so I get this equality. Looking into the previous equation, I see that I have an x plus 1. So this is my notation. So I need to find x plus 1. So I go back to the previous equation. I can see that I can have the x plus 1. So which means that I should take this term and move it to the other side of the equality. Then I can rewrite x plus 1 equals to this term minus this big term, rectangular term. So let's do that one. So that means that x, I can rewrite x plus 1 as here. x5 plus x4 plus x minus x3 plus x plus 1 times x2 plus x plus 1, right? And this is coming from here. All right, so remember that we don't want to, in the extended Euclidean algorithm, we don't want to really do the math. We just want to keep everything as it is, as a coefficient, and try to, summarize them. So this means that the entire thing that I get is x2 plus x plus 1 minus, if I apply this x on both sides, I get minus x, x5 plus x4 plus x plus x times x3 plus x plus 1, x2 plus x plus 1. Okay? So I didn't do anything. I just applied the x all over. Looking into the above equation, I have this reminder x2 plus x plus 1 so that I can I can kind of rewrite the above equation to get this one. So looking into my equation, I see that I have this in the both sides, right? Which suggests me that I should use that one as a factor. If I do so, I can say that this is equals to minus x times x5 plus x4 plus x. And then I can factor the rest based on this equation. So I keep it at the end. I can have plus 1 times plus this other factor, x times x3 plus x plus 1. This whole thing multiplied to x2 plus x plus 1, right? So I just rewrite the equation. So I brought this one over here, and I have these two factors. So I take this one here. If I get a factor from here, I just get 1 plus, if I get the factor of this term over here, I'll get x plus x3 plus x plus 1, right? So if I multiply them, I get the same thing. All right, cool so far. So which means that I get to x2 plus x plus 1. So going up, I can see that again, I can rewrite x2 plus x plus 1 by moving now this part to the other side of the equation. So given that, I can say that this equation equals to minus x, x5, plus x4 plus x, and then plus 1 times 1 plus x, x3 plus x plus 1. And then I can rewrite this x2 plus x plus 1 as this term minus this whole term over here. So I can say that x6 plus x5 plus x plus 1 minus x times x5 plus x4 plus x. Sorry that my x is not looking anymore like x. I'm just trying to write it faster. Okay, so we got ourselves a little bit bigger equation. Let's apply this math around and see what we would end up with. So I'll get minus x, x5 plus x4 plus x, plus I have to multiply this to the both sides. So I'll get 1 plus x, x3 plus x plus 1. Times x6 plus x5 plus x plus 1, okay? And then this is positive, this is negative, I get minus. I get 1 plus x, x3 plus x plus 1, multiply to this x, and then multiply to this one. x5 plus x4 plus x. All right, so let me go up and see what is the next reminder that I should play with is x5 plus x4 plus x. So x5 plus x4 plus x. So you need to have it in the both sides. So I now need to rewrite this thing. But before I do so, let me also sort of simplify this a little bit. So instead of keep writing this equation over here, so I would rename this one to be A. And then over here, it repeats. So I can say this is also A. I just change the variable, get a variable A to denote that to write less. So I can say that A times this term, x5 plus x1, minus, so what we can do is that we can factor these sides. We have a common coefficient over here, x5, x4, x, and then the same thing over here. So I can factor them. So if I get that, I can have from the first side, I get minus x. Actually, if I get minus that, so I can have plus x. So x plus, and then from this side, I will have A times x. And then the common coefficients, so which was x5 plus x4 plus x. Now that we have that, I end up with x5 plus x4 plus x. This is the last thing that I have to replace. So it looked like that I can rewrite this one. All I have to do is to move this thing on the other side of the equation. And if I do so, then I can rewrite this term as x8 plus x4 plus x3 plus x plus 1 minus x2 plus x plus 1, x6 plus x6 plus x5 plus x plus 1 plus x5 plus x4 plus x. All right. Let me see if I get it correctly. So I can rewrite that one as x8, right? X8 minus this thing. Okay. No. I don't have to have that last term, I guess. Yeah, that is correct.
X5.
Okay. Yeah. So all we have to do, as you see, we are iteratively removing what we have on the top. Let me double check.
Just the x5, I think that's the one we were trying to decompose, but you put it again.
Yeah. I shouldn't put this one. I'm sorry. Okay. So applying this to the both sides, we would get, it's a little bit of tedious computation, but bear with me to see the result at the end. So we get A times x6 plus x5 plus x plus 1 minus x plus ax. And then we get x8 plus x4 plus x3 plus x plus 1. And then I think that minus with this would become positive. X plus ax. And then we have x2 plus x plus 1. And then x6 plus x5 plus x plus 1. If we do some, rearranging over here, this is our P, right? Remember, and then this is our f. So we need to find, c times f, some c times f plus p times d, right? So that suggests that I need to keep f over here, and I would write whatever that is correlated to that. So I will keep x6 plus x5 plus x plus 1. And if I get a factor, I get a from here. And then from here, I get plus x plus ax, right? And then x2 plus x plus 1 from the other side. And then I have the remaining, which is minus x plus ax. And then x8 plus x4 plus x3 plus x plus 1, right? So this is my p, this is my f, this is my c, and this is my d, right? So if you do the math over here, I am not going to do that here. You would find that c equals to x7 plus x6 plus x4 plus x plus 1. And then that means that finally we found this c. So that means that if I multiply f times c now, I'm going to get 1 mod capital P, right? So which means that c is the inverse of our f function in the first place. And that's how we found it. So as you see, the computation is, it's a little bit tedious. So let me recap what we've done. So we started with our P over here and our F that we are interested to find the inverse. So we first tried to find their GCD. So that means that we start to divide them. So, divide this P by this F. And so according to its equation, we got this value and this reminder. And then we continue until we get the reminder to be 0. So we move this one here and this one over here as a quotient. And then we found x times this one plus this reminder equals to this equation. So we continue the reminder because reminder is not 0. And then we keep continuing by that until if we do one more line over here, the reminder would be 0 because we are going to divide x plus 1 divided by 1. So of course the reminder is going to be 0. So I just didn't write that. So since the GCD equals to 1, it means that f is coprime to p, right? So it means that we can find the inverse of f. So how do we find the inverse of f? According to the extended Euclidean algorithm, we have to work out from the bottom all the way to get to the up. So we said that 1 equals to this. If we move this term over here, so we can have x2 plus x plus 1 minus this term is equal to 1. So I wrote that one there. And we always need to keep an eye that we are going to work upward. So we always have to keep a coefficient of, this x plus 1 or x2 plus x plus x2 plus x plus 1 and so on and so forth. So rewriting it in this way, it helped me to have x plus 1. So given this equation, I can get x plus 1 as by moving this part over. So I get that one. And I move forward and I simplified a bit. And again, I try to get this, equation from the previous line. I kind of get that equation. So I got it here. And then I can rewrite this one again by moving this part over. So I substitute it and I do the math again. So we keep doing so. And then we know that the next term that we are interested on in x5 plus x4 plus x. So I found them here. So I try to factor them somehow that I get it over here. And again, I know that I can rewrite this term by moving this whole term on the left-hand side. So that's what I got over here. And if I continue, I noticed that this is the last line, and I got my f function and p function. So I kind of, this is also my f function. So I try to get a factor from that. So I just simplify them. And at the end, I was able to find my C function. So yeah, it is unfortunately a little bit tedious computation, but I think when you want to solve, if there's, for example, in your homework, there is one question related to this problem. So just need to be patient, make sure that you don't miss anything. Try to, even though you're sure about the steps, just make sure that you don't make any mistakes on any of these intermediate results, because if you do so, you have to rework most part of this problem again, and that would become a little bit tedious. So just like what I did, just try to write down these divisions for yourself, make sure that they're correct, and once you do so, then I think if you do it carefully, you shouldn't make any mistake, and then you will find the answer. So now if you go back to a part of the AES computation in a substitution byte, then you will find out that at some point we have to find the inverse of some f, which was a polynomial, and this is exactly how we can compute the inverse of those polynomials. I think I promise you that we would have some slides that I would give you more details of how can we do that computation. And this is exactly where we have discussed it in more details, and you have found that we are able to do this computation over here. So I hope that I think for the first time it is a bit awkward looking computation. So you can I'll send you the updated slides with the notation. So your mean term is going to be until the end of this chapter 3. And then all the material that we have covered in our introduction in crypto in section 2, which was symmetric based cryptography and algebra and number theory. These 3 chapters would be the basis for your midterm exam. Any questions?
I'm a little bit, well, I understand. I just I'm not fast. So I'm a bit worried that the midterm is going to be too long for me to finish on time. Like, is it going to be similar to the homework, or?
Yeah, more or less it's going to be very similar to the homework. But I think overall it's not going to be super difficult. I understand that, doing this computation would be very tedious. So we would choose, if I choose to give you a question like this for the midterm, I'll try to find a question that has less steps. I understand that you would have to do a lot of computation. So I hope that helps in overall on how. Just a second, my laptop is dying. Let me see if I can find a plug around me. Well, that is a bit far away. Let's see. All right, yeah, that looks to be okay. Yeah, I would send you, as I said, I will send you the updated list of this this last pages that we discussed. So soon you will receive it. No worries about that.